Okay, so first topic of second semester, we're going to start with numerical method here. So numerical method, there are three topics which are very simple in the syllabus. I will tell you. Okay, actually all the four topics are simple from my side. Only first topic, numerical method, is a lengthy topic. There are a number of articles are there. Then we come to the Laplace transform, which is a small topic actually. Laplace transform is small topic, but there you require little bit about trigonometric identities and integration formulae, that is in Laplace. Then statistical method, no prerequisite. It is one of the simplest topic that you have. And lastly, that Fourier series. Fourier series also require integration formulas and trigonometric identities. That basic. So prerequisite for semester 2 mathematics is trigonometric identities plus the integration formula. That is enough to complete your entire course there. Okay, that is a prerequisite of the course. So come to the numerical method now. So here first first topic of the course is solution of algebraic and transcendental equation. Okay, there are total three methods that you are going to learn: bisection method, regular falsi, and Newton-Raphson. So generally, yes, this topic will have 22 to 25 marks weightage in the final exam. So definitely, one 5-mark question will come from one of these three methods. Okay, so there will 5 marks weightage indirectly for this first article that you have. So solution of algebraic and transcendental. So the simplest method is a bisection method. Okay, come to that one. But before that, let me see the difference between algebraic and transcendental equation. Anyone knows what is the meaning of algebraic and transcendental? Yes, anyone knows what is a algebraic function and what is a transcendental function? No one. Okay, just laughing. Huh? Okay, so the equation which
So
take
the question,
uh, question is
so the equi
I'm asked. Okay, you are saying solution. Yeah, answer. Yeah.
so the equation in the form of fx equal to 0, where
Hmm. Hmm.
they are purely polynomial function, is
Okay.
called algebraic.
Okay, good. Means polynomial
Which
means in the form of x raised to n. Okay, correct.
yeah,
And what about transcendental?
they might include trigonometric, arithmetic,
Okay,
and
correct.
any
Very
other.
good. Very good. So, correct answer. So, the first one, algebraic equation, is the equation in which we have the terms of x raised to n only, that is algebraic terms only. But if the polynomial, if that function fx contains trigonometric, logarithmic, or exponential term, the equation is known as a transcendental equation. Okay. Now, here is this equation. Can you tell me whether it is algebraic or transcendental? Yes. What about algebraic? So you'll observe only the terms of x raised to n appears there. So it is algebraic equation. Next. What about this? What about this equation? Is it algebraic? This equation is not algebraic. This is a transcendental equation as it contains exponential and trigonometric term. So that about the second example. Remember, throughout this first article, we are going to find out the roots of these type of equation. Right now, you observed the equations are not so simple. If the equations are simple, like say y equal to x square, y equal to x square. Can you tell me what are the roots of this equation y equal to x square? Yes, anyone? If our equation is y is equal to x square, can you tell me the roots of the equation y equal to x square? Anyone? Quick. Y is like fx. Okay, y is equal to fx. So fx is x square. fx is x square and that x square is a 0. So what are the roots of this equation? Am I audible?
Yes, sir.
My,
Yes, sir.
is my question clear? x square equal to 0 के रूट्स क्या होने चाहिए?
So 0.
0 0, that's one. So simple. So because this is simple equation and you can easily solve that and you find out the roots of this equation as a 0 0, but actually it's a 0 only. How we get the roots actually graphically? If we plot this curve y equal to x square or fx equal to x square, if we plot this curve, the intersection of this curve with the x-axis, intersection of the curve with x-axis gives us the root. Okay, intersection of the curve with the x-axis gives us the root. So one of the way to get the root of this equation is we have to plot this curve. We have to we have to plot the curve. If we draw this curve and if we see the intersection of this curve with the x-axis, that point gives us the root there. But already this is a fourth degree equation. It's not so simple to plot it. So it took time there. Okay. But we have a numerical method now. The three numerical method that you are going to learn to get the roots of this type of equation by iteration method. By iteration method, we can get approximately uh, equal equal root of that equation there. And plotting this type of equation is also graphing this type of equation also complicated there. But yes, there are software. The softwares can draw this curve. Once you draw the curve with a software, that time also you can get the roots of this equation. But our aim is right now to get the roots of the equation by a numerical method there. So here is the first method. The name of a method is a bisection method. The name itself tells you the idea. Bisect means we have to divide it. So first of all, we are going to consider this function fx. This function fx defined on the interval ab, the interval a comma b. So if our function fx is defined on the interval ab, and say we have two values f of a and f of b, f of a and f of b. So our first restriction to apply this numerical method is this f of a and f of b should have a opposite sign. So if f of a is a positive, f of b should be negative, and if f of a is a negative, f of b should be positive. What happens with this condition? Can anyone tell me why this condition is there? Why this condition is there that one value should be less than and one value should be greater than there? Why this is a requirement? Why this is a requirement to get the root of the equation? Anyone have idea here? See, why this f of a is a negative? F of a is negative means whether this is in first quadrant or fourth quadrant.
4th.
Fourth. So let I say this is the point x equal to a. This is the point x equal to a, and this is f of a, because f of a is a negative. F of b is positive means it should be somewhere here. Is it?
First.
So this is, yes, f of b. So this is x equal to b. Now what happens because of this? See, our fx is a continuous function. Fx is a continuous function between x equal to a to b. So on this interval ab, fx is a continuous function, and f of a is less than 0, f of b is greater than 0. Because of that, we have a graph from this point to that point. So this graph may be like this. Okay, so automatically this graph cuts the x-axis at least in one point, and we get that root. This is x star. X star is a root that we have to find out. Okay, our aim is to get the root, and this root we can get it only when our function fx have the opposite signs there at the end point of the interval. So whatever the interval we are going to take it. So generally we take the two nearest integer. Whenever it is not given, we are searching for the two nearest integer for which f of a and f of b have the opposite sign. Once we get that two nearest integer where this condition satisfies, we start iterations. We start iteration to get that x star. Okay. So what is the first approximate value for that x star is x1. X1 is a plus b upon 2. Now depending on f of x1, suppose f of x1, once we get that, once we get that x1 and we calculate f of x1, we calculate f of x1. Now this f of sign of f of x1 is very important. Suppose f of x1 is greater than 0. F of x1 is greater than 0. That means f of x1 may be somewhere here then. Okay. For me, because f of x1 we said greater than 0. So f of x1 is greater than 0 and f of a is less than 0. Then what we can say, our root is now in the interval a to x1. A to x1. Why we taken a to x1? Because f of x1 becomes a positive. Suppose f of x1 becomes a negative, somewhere here x1 comes, f of x1 negative, somewhere here is f of x1. That time the root is from x1 to b. Okay, and this is a simple logic that we are going to use again and again to get a root of root by bisection method. Now what is the first thing that you should remember? This is the formula for iteration. What is the formula of iteration for bisection method? Is this x1 equal to a plus b upon 2. So x2 is equal to also a plus b upon 2, but we taken latest end values of the interval. We'll come to that. So here is the same thing that I explained on the previous. First, tell me what is the value of f of a? F of a is positive or negative? This is x equal to a.
Negative.
F of a is a negative. You'll observe this is f of a here. Okay. So this point have the coordinate a comma f of a. This is a comma f of a. And what about f of b?
Positive.
Positive. So this is a point.
Positive.
Yes, this is the point b comma f of b. So you'll observe f of a is less than 0, f of b is greater than 0. So we should calculate x1. So what is the formula for x1? This is the x1, a plus b upon 2. Suppose this x1 is nothing but this is a plus b upon 2, and that point comes somewhere here. It is just for rough diagram is there. Okay. So this is a plus b upon 2. So generally this is the mid value of the interval. Okay, so that you remember. What is f of x1 in this case? From this diagram, f of x1 is positive or negative?
Positive.
Yes, f of x1 is a positive. So where is the root now? So let I first show you here. First, here is this table we have to prepare in the exam for that particular equation. So n is nothing but number of iteration. This is a and b. So f of a, f of b. So you'll observe f of a is a negative, f of b is positive. So x1 is calculated with the formula a plus b upon 2. F of x1 we assume it is positive. So where is the root now? Root is in which interval now? Which smallest interval the root is there? Now already the bigger interval is AB. Now that should be reduced so that we narrow our search. Yes? Tell me fast.
So it would be in the positive interval only.
No, I'm
Like for the positive value.
no, I am asking the interval length from where to where. Just I said initial interval is AB. Initial interval is AB where the root is there. Now with respect to this 3 point A, x1 and B, whether the root is in between A to x1 or x1 to B.
X1 to B.
How x1 to b? Is the root is there in
Say a
between?
to x1 because
Obviously a
the
to.
graph is cutting at 0.
Okay, so this cutting is actually not looking in the table. The main condition for the root is in a to x1 is f of a is a negative while f of x1 is a positive. So this is the main criteria, main condition we are using for selecting the interval. So let I show you on the next iteration. Yes, this is the second iteration. Now this a, f of a is a negative, so a kept here as it is. Why b is replaced by x1? Because previously f of b is a positive and now f of x1 is positive. And the root is between a to x1 now. This x1 acts like a b now. And to calculate x2 now, to calculate x2, the formula will become a plus x1 upon 2. A plus x1 upon 2. Now what is f of x2? Positive or negative? f of x2 is a positive or negative. Here is x2
Negative.
negative. Here it is written also. Suppose f of x2 is a negative here. So f of x2 is a negative. Now, which is the smallest interval in which that root is there? What is the next interval? We should take it.
x1 and x2.
Yeah, correct. So I will say x2 to x1. Okay, actually x2 to x1, because f of x2 is a negative, x1 is a positive. So you can say x1 to x2 also, not a problem. So you'll observe A is replaced by x2 now, because previously f of A is a negative, now f of x2 is a negative. Okay, so this is the new interval that we have. We get x3. Suppose x3 is a negative. So what should be the next interval then? Suppose f of x3 is a negative. What is the next interval where we get a root then?
x3 to x1.
Correct, very good. X3 to x1 is a correct answer. And this is the same thing. What happens in all these things, you will observe initially the interval is a bigger. Every time it is a reduced by half. The interval is a length of the interval is a reduced by half, because we use a bisection method. So after more number of iteration, obviously you are looking for the exact root in a smallest interval, where you get an approximate value of that root. So you can easily,
So,
yes,
so can we take x2 to b?
x2 to b, for which iteration?
So for a fourth iteration.
Why you are going to, if you why you are going to take x2 to b if you already available there is a small interval? If you take a larger interval, what happens? Your iteration will increase. That's only. Because if you have this interval again and again, so the number of iteration to get a good accuracy will be the with a less iterations here with a small interval. Na? Suppose you know that the root is at x equal to 5, suppose.
So one more question I
Yeah.
have.
Mm-hmm.
Sir, if x1 came
0 only.
negative,
Uh-huh.
then we have to take x1 to b.
Yeah, correct, because f of x1 is negative and f of b is positive, then the interval is obviously
So
x1 to b. So
okay,
it depends entirely on the sign of f of x1. Okay,
okay, sir,
correct.
understood.
Okay, so that's a simple logic. It is used for getting the roots, and we have to go till the desired accuracy. Now, what is the desired accuracy? Because many times in the question paper, it's not given how much iteration you have to do it, how much decimals you should be correct. So in such a case, you should do minimum. If it is a bisection method, na, you should do the minimum 6 to 7 iteration, because bisection is a very simple method. It is just considering the sign and you have to half the interval each time. So minimum, and it is actually simple method, but drawback of the method is it takes more number of iteration only. Newton-Raphson, the third method that you are going to learn, it have some difficult formula than the bisection, but the best part is the number of iterations are hardly one or two. Only one or two iteration you have to do it to get the good approximate root there. Okay, we'll come to that later on. So here is the first example. This example is from your question paper already, from old question paper. The question is, solve this equation x cube minus 9x plus 1 equal to 0 for the root lying between 2 and 3. So what is the best part in the question? Right now you are given these 2 and 3 as a end coordinates of the interval already. So 2 nearest integer is already given. If it is not given, what is our first important thing? That we have
A
to
and B.
find out a and b. Correct. We have to replace x by 0, and you have to check f of 0 is positive. Okay, f of 0 is positive. Then we'll replace x by 1. Then you will observe f of 1 is also positive. Then you will replace x by 2. Probably then it becomes positive and f of 3 become negative. Something like that may happen. And then you will come to know that between 2 and 3 there is a root. Actually the root is in between 0 and 3 also, because if f of 0 is negative, f of 3 is positive, the root is also between 0 and 3, but it is a larger interval. Why to take a larger interval? If we have a smaller interval, the number of iterations are less, so better to take a smaller interval. Is that clear?
Yes, sir.
Okay, so this question is already given, so you should not worry. Now remember, for at least for this session one, chapter one, numerical method, and the statistical method, chapter three. These two chapters, scientific calculator is important. You should keep a scientific calculator with you whenever there is class, because you should have a good practice on a calculator. At the end, you may not know that how to use this calculator then. Okay, so you should keep a regular practice there. Now, what should be x1? Any guess there? A is a 2, B is a 3. So what should be x1?
2.5.
2.5, correct. So I'll just 1 minute. So here is that question. I know this is very small window, but I think you can read it. So you'll observe this first iteration. So n is equal to 1, you should write. This A is 2, B is 3. Then f of a. F of a is just, I'm not interested in its value. I'm interested in sign. You will observe f of 2 is a negative. You can replace x by 2 and you can check. What is f of 2? Yes, anyone? 8 minus 18 plus 1. Not 8, sorry.
-9.
Yes, it is 8, correct. Only. Minus 9, huh? Correct. 2 cube is 8. 8 minus 18 plus 1 is a minus 9. So f of a is a negative. It is written negative. What is f of b? If you replace 27 minus 18 plus 1, it is a positive. So negative, positive. So 2.5 we got as a first. What is f of 2.5? Now you have to check it on calculator. Is it negative? F of 2.5, is that negative?
Okay.
Yes?
Sir,
Huh?
sir, sir,
Hmm.
sir, if 3 is positive,
Hmm.
f f of 3 is positive, then and it's written in the question that is 6 stages, then absolutely 2.5 should come negative, no?
No, not necessary. It depends on the graph. If where the
Sir,
graph.
if it doesn't come 2.5 negative,
Hmm.
then what value we should take to 6 stages?
Pardon. What?
Sir, sir,
Hmm.
if in place of x1 some other value come
Huh.
and it gives the positive one,
Huh.
then how to?
Yes, if it is positive, see, when we got x1, x1 is obviously the center value of the interval. So 2 and 3, the center is a 2.5. So you got x1. Now we calculate f of x1. F of x1, if it comes negative, it indicates we have to replace a by x1. Because why we replace a by x1? Because f of a is also negative and f of x1 is also negative. So negative value will replace to the negative value and the positive value will replace to the positive value. Suppose f of x1 comes positive, then we have to replace b by x1. That means,
Okay, sir.
okay,
Okay, sir.
so that interval will change only. Right now, what is the next interval? Tell me, in which interval the root is there now?
Sir, 2.5 to 3.
2.5 to 3, that is a correct answer, because you will observe f of a is a negative and f of 2.5 is also negative. So you will observe this is the second iteration we started. So we taken here, you can observe that 2.5 to 3 is a taken. Now f of 2.5 is negative, f of 3 is a positive. So where is the root? First we will calculate x2. What is x2? Probably
2.75.
2.75, correct. Now 2.75, here again f of 2.75 comes a negative again. You can check on calculator. You have to replace x by 2.75 here. Like 2.75 cube minus 9 into 2.75 plus 1. It comes negative there. So what is the next interval now? What is the next interval where the root is there? Yes, quick. What will be the next interval? Hello? I'm not getting any answer. Hello?
2.75 to 3.
Correct. That's one. So you should give the quick answer, no? So correct. Good. Very good. It is 2.75 to 3 because f of 2.75 negative, f of 3 is positive, and the root is there. So the next value will come 2.75 plus 3 upon 2. Okay, so that value coming 2 point, you will observe it is a 2.875. 2.875. So f of x3 you have to calculate on calculator. Now again it is coming negative. Okay, right now it is continuously replacing only a there, but sometimes it may replace to b also depending on the graph, what graph we have there for that function. So the new interval reduces to, now new interval reduces to 2.875 to 3. You will observe the next interval is 2.875 to 3, and so on. I will continue here. I will open all these things here, and I'll just show you here. You will observe this is the final result that you have. Now you will observe uh, in the first iteration the approximate root is a 2.5. In the second iteration, n is 2, means second iteration, we have 2.75. In the sixth iteration we got approximate root as a 2.95. You'll observe here is a 2.93, here is 2.96, here is 2.95. So it is mainly, you see here sign is also changed. Here sign is also changed. F of x5 comes a positive. Got it? So as f of x5 comes a positive, the root lies between that. You have to replace actually b there. So this is the x5 and x4. This is actually x4, x5 there, and you got 2.95. So it is roughly, the digits are now matching there. At least this is correct up to one decimal. After sixth iteration, the correct root up to one decimal place is a 2.95. Actually, whenever one decimal start repeating, one of the decimals start repeating, it is correct up to one decimal. Probably if you take seventh iteration, you may get 2.957. Okay, that means you get a correct up to two decimal places that way. So in final exam also, you should do this minimum six iteration for bisection method. Got it? Any doubt there, anyone? Yes. Here in the question, the 6 stages is written.
Sir,
6 stages means six iteration. Yeah. Yes, your question.
sir, this is not the actual root. No?
This is not actual. It is near to the actual root. Probably the
Okay.
actual root may be 2.98. Okay. It may be there. But it is approximate to that. It is closer to that, obviously. When you get large number of iterations, say 100 iteration, you get exact root. But yes, right now the computer, whatever you have the calculator. Remember, this calculator gives you root by these numerical methods only. So all calculators are programmed by numerical methods only. There is nothing like that. You enter that coefficient and it mainly does some calculation there, instead of means calculation in the sense means the program to solve that equation. Instead of solving that equation, numerical methods are generally preferred for programming. Okay, in programming numerical methods are mainly preferred. Any doubt? Any other doubt? Mick? Yes, no doubt. Okay, actually 5 minutes are left.